Hello everyone, my name is Victor and today I go to talk about a hot topic in the field of computer vision. This is image segmentation. So in this 5 minutes video I go to explain the main features of this topic. First one, what is image segmentation? In simple words, it's the task of separating regions of one image and assigning them different labels. In this example, we can see an image of a common street and their output using image segmentation, where we can identify different objects such as cars, buildings, people, sky, and so on. In this way, each pixel of our original image is classified under a specific label. Currently, different applications have been developed using this approach, being useful for instance in healthcare diagnosis and treatment. We can observe here how in a MRI scanner we can identify specific things such as aorta, which is the main artery that carries blood away from your heart to the rest of the body. Also, we can mention other kind of applications in robotics, such as helping with the selection of particular items in a container, as well as in the field of self-driving cars, helping to recognize elements in the environment, which is important to take decisions in the road. Now we can focus on how does image segmentation work. As this topic has been widely developed for more than 4 decades, we can split it in two main parts. Traditional methods, typically using algorithms from digital image processing, and deep learning based methods, which have had more success in the last years. Each one of these branches considers a lot of algorithms. For instance, in traditional techniques, we can mention the use of threshold and edge methods, which are some of the most typical and easy to implement. For instance, here we can see how defining a threshold in one image, we can enclose part of this based on the color of each pixel. Meanwhile, here we can visualize an edge detection process which mainly based on the use of filters to detect the borders of elements in the image. Now we go to mention some of the main algorithms used in deep learning. There is a bunch of them, however, UNet, DeepLab, SegNet, MassRCNN, FastFCNN, and Gated SCNN are some of the most popular algorithms used in the last years. Overall, these techniques are based on the same pioneer, fully convolutional networks or FCNN. To understand the basic operation of FCN, we can see this illustration. First part considers the typical structure of a convolutional neural network for a classification task. In a nutshell, this part is compounded by a series of convolutional and pooling layers whose function is reduce the size of the original image, creating feature maps. These feature maps contain the relevant features of this image, removing the less relevant information, making at the same time a downsampling of our image. The second part considers the use of a transposed convolutional layer, which allows to increase the size of our output, recovering the spatial information. In this way, we can get a classification at a pixel level. Now we can think that in general, most deep learning methods follow the same idea. Mostly, they have an encoder part, which is responsible to decrease the size of one image and get the main features of that image. Later, the decoder increases the size of the previous output and returns an array of the same size of the input image, but with the classification of pixels. Overall, this is the base of each deep learning model for segmentation task. Now we go to show some experiments using DeepLab and FCN in Python. First experiment considered this simple image with 2 people and 2 dogs, and now we can see the results given by these two models. We can say that there is a great accuracy in the detection of people and animals, and also we can say that the performance in both cases is similar. Now in experiment 2 we have 4 people with their bicycles. And results demonstrate again a great performance given by these two models. If we pay attention of a specific region of this image, we can observe some subtle differences in the results, being DeepLab 3 a little more accurate. Now, the third example considers a lot of cyclists riding in a road. And despite the presence of multiple objects in one image, both models can detect them in a marvelous way. Finally, I want to mention some important things about image segmentation. As you can see, this is a hot topic in deep learning and in computer vision. There are also several approaches available, and each year more novel and powerful methods are released. Some of the last researchers, for example, have been focused on creating more efficient models to be able to run in edge devices. For instance, in this paper is mentioned ADENSET, which is one of the most famous models of the year 2021, which outperforming the main competitors as RefineNet in terms of efficiency and memory. In the end, we can mention that there are powerful applications which has been developed in different industries as transport, agriculture, and medicine, and is expected that in future years more industries incorporate image or video segmentation in their processes. Here are some of the references used in this video, and thanks for watching. Bye and have a good day.